Namashivaya. My name is Sanjay Raju and I'm roll number 57. So the problem that we'll be solving today is called the longest common subsequence. So what is this problem? So basically it is giving us two input strings and our objective is to find the longest common subsequence and its length. So the return value has to be an integer, which is the length of the longest common subsequence. What is the longest common subsequence? So basically it is so there are characters and they'll be giving two identical suppose we're given two strings and they will be selecting identical characters from both the strings and they make up a subsequence. So we are trying to find the longest subsequence that we can make and return its length. So how are we implementing it? We have two methods using one is using recursive formulation and the other is using a bottom-up method here in dynamic programming. So let us explore the recursive formulation method first. So in the recursive formulation method, let me use, okay. So in the recursive formulation, so suppose we are given two strings as str1 and str2 of x and y length respectively, and we'll be solving this problem using the help of matrices. So we'll be initializing a matrix of x and y length, and in the recursive formulation method, what we have is within the matrix. In the recursive formulation method, we will be storing 0 if n and m is 0. Why are we doing this? Is because if n or m equal to 0, n and m are the length of the strings respectively. So if they are equal to 0, it means that the string does not exist, which means the value in the matrix should be 0. And if we are within a string, when we are comparing, if a character is in str1 is equal to a character in str2 at the n and mth location respectively, what we do is increment 1 to the column value of the previous location within the matrix. So why we are doing this is because to keep track of the count, which is the length of the common matrix, and we'll be incrementing 1 to it when we find a common string, and we'll be storing it to the matrix at the n and mth location. In case we come to a scenario where n or mth location is not equal to each other, what we do is we'll take the max of we'll find the we'll do recursion. We'll consider the nth location in the str1 and we'll not consider the mth location in str2 and vice versa, and we'll follow both the methods using a recursive form, and we'll return the max value of either of them and store it into the n and mth location. So this is very effective, but the problem is this can have infinite number of steps since it is recursion, which brings us to dynamic programming method. So in this method, what we are doing is we are initializing, let me show you. What we do is we initialize two matrix of n x plus 1 and y plus 1 length respectively, and we'll keep the first first row and column respectively as 0. The whole row and column will contain the value 0. Why this is done is we're storing the initial count as 0, and that is what we're doing with this line over here. And doing finding the lowest common subsequence problem will similar to recursion. We are storing the value of the previous location plus 1 if they are equal, and we'll find the max value from the matrix. We're doing LCS of n and m minus 1 and n minus 1 and m, which is the previous we are comparing values by not considering the character within each string respectively. And finally, after doing and iterating over this using a loop, a nested loop, we're using a nested loop in dynamic programming. will return the value at n and mth location, which will contain the length of the biggest common substring within the two strings. So that is the method used. And since we're using a matrix of n and m dimensions, respect n into m dimension, the space complexity of the program will be big O of m into n, which is the dimensions, and the time complexity will also be big O of m into n, since we are using a nested loop to traverse through all the cells within the matrix. So let us implement the code. So first, what do? Initially we are checking if both the strings exist. So how do we do that is we take the length and equate it to 0. If it we take the length of both the strings, that is text1 and text2, and equate it to 0, equal to 0. So if it is equal to 0, which it means that neither of the strings either of the strings do not exist, and then if that is true, then we return 0. Coming down, we'll store the values of text1 and text2 in the n and m respectively, or m and n. So int m equals text1 dot length, and int n equals text2 dot length. Okay, we stored the values, and now we initialize the matrix that I've said. So matrix, we'll call the matrix common, since we are trying to find the longest common substring, is equal to new int n plus 1 and n plus 1. Now, since we have a string, we need to compare characters. What we do is we are converting the string into a character using toChar array built-in function in Java. So, and then we can store it to a character array. So let's call chr1 equals text1 dot to char array. chr2 equals dot to char array. So we are storing the values of each string into character arrays, with each element being the characters. Now what we do is we are traversing through each and every location within the matrix, which will give us a time complexity of big O of m into n. So in int I equals 0 and I less than or equal to x, and I plus plus for int j equals 0, j less than or equal to y, and j plus plus. I'm sorry, so we have to start it for I equal to 1 and j equal to 1. Since we have to compare the current, since the first row and column are 0, we are not considering it. We are going to the second row and column, and we are taking the value of the first row and column by I minus 1 and j minus 1. So first we'll compare the values in the first row and column. So if chr1 of I minus 1 equal to chr2 of j minus 1, which in this case I and j equal to 1, so we're checking the first cell, which is 0, and so what this means is if value the first element, first is character in string 1 and string 2 is equal, we are incrementing the longer common subsequence length by 1. And how we are doing that is we take the previous value within the matrix. In the matrix I and j, which is the current location, that is I 1 1. So we in this method, what we do is whenever we find a common character, we increment the value in the diagonal, right lower diagonal, and we go towards the end point, which is common MN, which will be the final location where the longest subsequences length exists. We'll store in the ij location. We'll store the value of previous previous locations I minus 1 and j minus 1. I minus 1 and j minus 1 in this case will be common 0 0. The matrix 0 0, the 0 0 the location, and we'll increment the value of 1 and store it into ij location. Else, if they're not equal, what do? We'll find the max value of the previous location, which will be either to the left of it or to the top of it in the matrix. Well, in actuality, what this is doing is we are comparing the if n and mth location in two strings respectively is not equal, we'll compare the nth location in one string with the n minus 1th location in the other string, or the n minus 1th location in the first string to the mth location in the second string, and we'll return the highest value. So common and I minus 1 and j, we are comparing I minus 1 and jth location to I and j minus 1th location, I and j minus 1th location. We are comparing to it and returning the max value. Where are we storing it? We are storing it in the current location. And I and jth location, we are storing it in I jth location. Okay, so and then finally, after traversing through all the locations and updating the values, we are returning the m and nth location within the matrix, m and nth location within the matrix. So this location will have the length of the longest common subsequence. If I'm right, this code should work perfectly. Okay, I can do an error. Okay, sorry. This should be M and this should be N. Okay, now let's. Okay, so it got accepted. So the inputs are A, B, C, D, E, and ACE. In this, ACE is a direct substring of A, B, C, D, E, where the randomness of the characters doesn't matter, but then the substring has to occur in the relative order of the first string, and the length of the substring, which is ACE, is 3, and the output is also 3. Let's submit it. It got accepted and 99.919% faster. Okay, so this is it, and from this we know the time complexity will be big O of m into n, depending on the size of the string, and the space complexity will also be big O of m into n due to the matrix that we are using. There is a relatively easier method which is using hash map, but we are using this. Okay, so this is how you solve the problems. Thanks for listening. Nam Shivaya.